Hello and welcome to this presentation for the Experimental Archaeology Conference of March 2021. This presentation is going to focus on the results of an experiment to quantify fuel consumption in a hearth burned over a 24-hour period and used for a variety of functional purposes. This experiment is part of a larger investigation into fuel supply and fuel consumption that I'm leading here at the University of Exeter. Now, there are different ways that we could study a firewood economy. One would be to look at the sourcing of the fuel, so looking at how much dead wood is produced naturally in given ecosystems. Once you've burned through the available fuel, how long does it take for those supplies to replenish and to build back up naturally? What kind of fuel management strategies have people used in the past in terms of do you go out and deliberately ring bark trees to kill them in order to produce your firewood for future years? However, another aspect of the firewood economy is clearly the fuel consumption element. How much fuel do you actually need to survive? How much wood is being burned on a daily basis? Now, clearly this is going to depend on a huge number of different variables. I'm just going to explore some of those on the next slide. But if we want to study the firewood economies of the past, we do need to have some handle on this element of firewood consumption too. Now, when designing a fuel consumption experiment, this is fraught with difficulty because the range of potential variables that you could consider is enormous. And for this reason, we explicitly in this test did not seek to replicate a hearth from any particular archaeological site or time period. Now, this list here, it just lists some of the possible variables that might affect your fuel consumption and how much fuel that you need. I'm sure there's more that you could also add to this list. And indeed, in a real life situation, a lot of these variables might also be expected to vary across the course of a 24-hour window as well. For example, ambient temperature or the fuel, the species of wood fuel that you are burning. And it's not possible to easily define what any of these should be for an experiment that's in a way that's particularly meaningful. It's also not clear exactly what we would be trying to replicate in any case. When we find hearths archaeologically, we can document how large they are in terms of a diameter, and we can reconstruct some of the activities which took place around them. But we have no information about some pretty important variables. For example, how long were fires actually lit for? Is it possible that these fires were burning continuously over a 24-hour period or for the entire time the site was occupied? Or are they being extinguished and rekindled on a daily basis instead? So for this reason, we defined the aims for our experiment in rather general terms. So it's the intention of documenting a situation which was as natural as possible. The aim was to quantify fuel consumption when burning a functional open-air campfire used for 24 hours for things like cooking, heat and light and various technological activities along the way. The setting that we used for this experiment was a woodland setting of mixed deciduous and conifer species. Now, this wood has been used for a setting for the delivery of bushcraft courses, including firelighting courses with overnight stays, for about 25 years now. So it's estimated that fires have been lit in this woodland for around 200 hours per month every year for the past 25 years or so. Now, this equates to about 2,400 hours of burning campfires per year for those 25 years. So in no way can we say that this woodland setting is a virgin woodland setting. Rather, it is simulating a regular campsite location that's obviously been used regularly for many, many years. Now, the most recent one of these firelighting courses took place about 6 months prior to the point when we did our experiment. And this means that the most obvious dead wood that was available for us to burn was that which had been produced naturally within this woodland over the intervening 6 months window. The team on the ground consisted of 3 people, and all of us were experienced and proficient with fire management skills. It's also important to note that one of our number was the bushcraft teacher himself, Johnny Crockett, who you see in this photo here, and he has more than 25 experience of teaching firelighting and bushcraft skills. And it was important that we were able to draw on his experience during the course of this experiment. This image actually shows him starting the fire at the beginning of the day using the fungus chaga and some straw. We also set ourselves some simple rules to guide how we would use the fire, and this includes adding firewood as and when we felt it was needed, just to make sure that heat or a bed of embers at least was maintained at all times. The main aim here was to use fuel but without being wasteful of it. So don't add fuel for the sake of it. It was just taking a rather minimalist approach to that, where options were where the choices were to be made. We also decided in advance that we could use any fire management strategies that we deemed fit at the time, including moving wood around or stacking it on the fire, however we determined would be best, and doing things like drying wood out beside the fire to remove residual moisture before sticks were burned as well. We deliberately chose to do this experiment during the late British winter, expecting that we might get non-ideal weather conditions for the day that we were doing it. And this acknowledges the fact that people in the past also rarely experienced ideal weather conditions themselves. So, for example, it had been raining periodically for the 3 days prior to this experiment taking place, and we also got a few spots of rain during the experiment itself. And this meant that all of our fuel was damp, and we had to deal with that by drying it out by the fire as much as possible before putting it on. For fuel, we also only collected firewood that was available easily to collect by hand, and in that process was weeding out the wettest of the firewood and just chose the driest stuff that we were able to find, although most of this did come from the forest floor rather than from trapped in trees. The activities that we undertook included the cooking, boiling water with hot rocks, making mastics, and then just using the fire for heat and light and comfort as well. So our results. In the end, we had a pretty nice day actually for this experiment. We had some sunshine during the day, and it was a mild night where temperatures didn't go below 8 degrees. The wind speed remained low, but the humidity was rather high, up to almost 100% during the night. One of the main activities that we took during the 24 hours was cooking, and this included cooking with a roasting pit that was lined with hot rocks. Now, the rocks that we used for this were wet when we collected them, so we had to warm them up slowly over a period of time beside the fire. We then built up the fire into a big mound, which you can see on the right-hand side here, to get the rocks absolutely as hot as possible before they were transferred to the pit. They were then buried together with the food and left for almost 4 hours with it to cook. For those of you who aren't familiar with the idea of cooking with hot rocks, this is a diagram that I've taken from the paper by Toms in 2009. And here you can see the hot rocks are laid on the floor of the pit. You then pack in the food on top of that, together with some leafy packing material, and you then bury the whole thing with earth to allow the heat to cook the food. Now, this image here shows us uncovering the pit in the evening time to see whether it worked or not, and indeed it had, although we did have to finish off some of the vegetables on top of the fire just to fully tenderize them through. And I can confirm that it was an extremely tasty dinner. We also conducted a variety of other activities with this fire over the 24-hour period, including the preparation of mastics, arrow straightening, boiling water with hot rocks. And you can see we cheated here by using a metal saucepan for this. And then in the morning, cooking breakfast. You can see these are goose eggs that we're cooking here. So in total, we burned through almost 113 kilograms of dead wood fuel, and this was almost entirely hardwood from a mix of species, which you can see documented separately in the table here on the right-hand side. It was actually possible to gather all of this, the dead wood fuel, from a radius of within 50 meters of the hearth itself. It's really quite easy to do this in this particular woodland setting. Most of the branches were small in diameter, and we didn't collect anything larger than 9 centimeters in diameter. As I've already said, we collected only the driest wood that was available, trying to weed out all of the wettest wood. But because of the rain showers over the previous few days, it meant that all of this wood was still damp, with humidity readings up to 35%. Now, we attempted to dry this wood fuel out as much as possible by laying it around the fire before adding it, but in practice, none of the wood was completely dry by the time we put it on, and it meant the fire was hissing pretty much the entire 24-hour period. The nature of the fire varied naturally throughout the day, so at times there was bright, strong flames, and at other times there were no flames at all. It was purely embers. And we consider this to be a perfectly normal way of a fire being managed, and how it will change naturally over the course of a 24-hour window, according to what's happening at that given time. This graph tries to illustrate how the fuel consumption rates changed across the course of the 24-hour period. in relation to some of the different activities that were being conducted. Now, actually, this graph is actually shows a fairly consistent, a surprisingly consistent rate of fuel consumption over the course of the 24-hour period, given all of the different activities being conducted. Now, one of the reasons for this is that the larger bits of wood that we had, some of the branches were a couple of meters long. These were not all burned immediately when they're added to the fire. They're fed slowly in over the course of several hours, and this has the effect of flattening this curve somewhat. I didn't find a way of being able to easily document how much of these branches was being added per hour, and for this reason, I think that this graph is flatter than it otherwise would be. It doesn't nicely show some of the peaks in fuel consumption which did occur on an hourly basis with respect to these different activities. Another thing that was surprising is that after 4 o'clock in the morning, this is 18 hours into the experiment, we didn't need to collect any more wood fuel, and in fact at this point the fire was maintained simply by feeding in the ends of bits of wood which hadn't fully burned through, and also just simply relying on the embers as well. It got light. The sun didn't come up until after 6 o'clock, but it was light enough to see by well before that, actually. So this was another reason that we no longer needed strong and bright flames in order to see at this time. In terms of temperature, these documents the hottest temperature reading that we were able to obtain from the fire at the point the measurement was taken, and you can see that it varied mostly between about 550 and 750 degrees Celsius for the majority of the 24-hour window. It did occasionally peak above 800 degrees, and it did also fall when we deliberately wanted this to create embers for cooking, and that's for cooking our dinner and for cooking our breakfast in the morning as well. So just a few reflections to take away. Our results have indicated an average hourly consumption rate across the 24 hours of 4.9 kilograms of dead wood per hour. Now, this figure is within the similar ballpark range to the few existing data points that I've seen for this in the literature when similar kind of experiments are being conducted, although it is on the higher end of most of those estimates. Our reasons for this, it might be because we had to collect fuel which was slightly damp, and we have recorded the weight at collection rather than the weight of it being added at the moment it was added to the fire, where some of that moisture might have been dried off. But it could also be because we used our hearth for a variety of these different functional activities, including heating up lots of rocks, and this is widely regarded as being a fuel-intensive activity, which could be the other reason for increasing our fuel consumption rates a bit. A second point is that the firewood collection itself was very, very simple, and this was helped by the fact that this was the first campfire to have been lit in these woods for about 6 months. In that intervening window, since the previous fires, we've had winter storms which have brought down plenty of fresh dead wood for us to pick from. And in a mature mixed woodland setting like this, it's clear that this kind of environment can sustain this level of firewood collection quite easily and probably for quite a significant period of time. However, it won't be indefinitely. There will be a limit after which you will have consumed the dead wood fuel that's naturally produced, and I'm going to try and calculate now a figure for that using these kind of estimates of fuel consumption that we've determined here. Thirdly, it was difficult to measure the fuel consumption rate by hour during this course of this time, just simply because the wood is burned slowly over a period of time. The total fuel consumption consumed over 24 hours is still very accurate, but this fuel consumption per time is smooth, and this isn't a particularly easy problem to solve to try and document that according to how the changing use of the fire has changed your fuel consumption rates. Finally, this experiment is just the first step in what we hope will be a series of tests exploring fuel consumption in different scenarios. Our next step is going to be to repeat this experiment in a conifer woodland where we're burning only softwoods, and this is replicating something more similar to the Paleolithic environments that I'm particularly interested in myself. But we also want to see what happens when we increase the number of people around the fire from the 3 people who are present here to groups up to maybe 7 or 8 people in size, and then even up to 10 or 15 people in size as well, because it's clearly going to be a completely different ball game there. So I hope that you've enjoyed this presentation. Thank you for listening, and I look forward to any questions that you have in the discussion part of this conference.